Section 6.2 is on factoring trinomials of the form x squared plus bx plus c. So this is a little more challenging. What we end up noticing is that if we had given x squared plus 4x plus 3, what we notice is that we could break that up as x squared plus x plus 3x plus 3. We could factor that by grouping. We get x times the quantity x plus 1 plus 3 times the quantity x plus 1, and that gives us the quantity x plus 3 times the quantity x plus 1. And alternatively, we could have written it as x squared plus 3x plus x plus 3, and then we can factor that as x times the quantity x plus 3 plus 1 times the quantity x plus 3, and we still get x plus 1, the quantity x plus 1 times the quantity x plus 3. So you'll notice it doesn't actually matter what order we do things in. And so what we're going to see is that in general, if we can determine factors m and n such that m times n equals c and m plus n equals b, we will have a factorization x plus m times x plus n equal to x squared plus bx plus c. And we can see that by factoring by grouping. But we don't actually need to do the factoring by grouping, because if we have x squared plus bx plus c, once we find the correct m and n, that factorization is always going to work. So if we looked at x squared plus 7x plus 12, we notice we have to go down the list of factors of 12. We look at 1 and 12, adds up to 13. 2 and 6 adds up to 8. 3 and 4 adds up to 7. And that works. So we notice that we can say x squared plus 3x plus 4x plus 12 equals x times the quantity x plus 3 plus 4 times the quantity x plus 3, which gives us the quantity x plus 4 times the quantity x plus 3, but we notice that we could have just written x plus 4 times x plus 3 as soon as we had that pair of factors 3 and 4. It's interesting to notice that once we've got the x squared and the c, there's actually a very short list of possible things that can be factored. So we notice that with 12, we had a choice of 13, 8, 7. We could also have done negative 1, negative 12 would have given us negative 13, negative 2, negative 6 would have given us negative 8, negative 3, negative 4 gives us negative 7. We notice if we had said x squared plus, let's do x squared minus 8x plus 12, we know that is going to be x minus 2, x minus 6, just by looking at negative 2 plus negative 6 is negative 8, negative 2 times negative 6 is positive 12. So if we have the product is equal to c and the sum is equal to b, we have our factorization. On the other hand, if we had said x squared plus 5x plus 12, we notice that none of those choices is a 5. This cannot be factored as binomial factors. And in general, any polynomial that cannot be factored is called a prime polynomial. So if we looked at x squared minus 3x minus 12, we notice we can find out whether it can be factored or if it's prime. We have our negative 12. We make our list of possible factorizations. Negative 1 times 12, negative 2 times 6, negative 3 times 4, and then we have the opposites. We could have 1 negative 12, 2 negative 6, 3 negative 4, and so you notice you don't necessarily have to write out all of the negatives. We notice that if we happen to have a factorization, if we looked at x squared minus 11x minus 12, we notice that we have negative 1 plus 12 is 11, and so we notice if we just reverse the signs, we get negative 11, and so we can just say this one is going to be x plus 1, x minus 12. So instead of using minus 1 plus 12, we use negative plus 1 minus 12 to get the opposite sign for the negative 11x. But you notice that none of these sums, we get a sum of 11, a sum of 4, a sum of 1, negative 11, negative 4, negative 1. None of those is a negative 3, and so that original x squared minus 3x minus 12 is prime. So let's try a couple more examples. If we had m squared minus 7m minus 8, we notice we can, that's when if they differ by 1, you'll notice you'll sometimes get nice things happening. We notice that negative 8 times positive 1 is negative 8, negative 8 plus 1 is negative 7, and so we know that's going to wind up being m minus 8, the quantity m minus 8 times the quantity m plus 1. If we had z squared minus 4z plus 4, this is something we're going to talk about in a later section. We notice that 4, we have the choice of 1 and 4, 2 and 2, negative 2, negative 2, negative 1, negative 4. We notice negative 2 plus negative 2 equals negative 4, and so we can say z minus 2 times the quantity z minus 2, and so we're going to leave it as the quantity z minus 2 times the quantity z minus 2, or we could think of that as z minus 2 quantity squared. And again, we're going to talk about that a little bit later. That ends up being a neat trick we can use. If we looked at one with a bit bigger numbers, if we tried looking at p squared minus, let's make it this way, yeah. So if we had p squared minus 13p minus 30, you notice that the bigger the value of c, the more work we have to do. We notice that negative 30, we have to look at negative 1 and positive 30, negative 2 and positive 15. We notice negative 1 plus 30 is 29, negative 2 plus 15 is 13, and so you notice that we can stop because we got the positive 13, we need a negative 13, so we just swap it around. 2 and negative 15 adds up to negative 13, and so our factorization is going to be p plus 2, the quantity p plus 2 times the quantity p minus 15. And you notice if we had done that by factoring by grouping, just to remind you of that, if we took p squared plus 2p minus 15p minus 30, we would pull out a factor of p to get p times the quantity p plus 2 minus 15 times the quantity p plus 2, and that's going to give us the quantity p minus 15 times the quantity p plus 2.